Hello everyone, and welcome back to the garage. Today we are going to get started doing the restoration of this 1986 Bally Strange Science pinball machine. In a relatively recent video, we took a look at this machine. We took a look in the back box and discovered that it had a very odd looking handmade board that apparently is supposed to light up the balls in the trough. So we'll have to take a look at that and see if that's what's actually doing. We also took a look underneath the play field and found it to be in very good shape, just a little bit dirty. And I have seen pictures of this machine turned on, so I know that it actually comes to life. So let's go ahead and take a brief look at it once again, and then we'll get it fired up. Let's get started. So here we have our Bally Strange Science from 1986. You can see the backlash in this machine is in basically perfect condition. Looks very nice. That is a neon topper on the top of the back box, and that is factory. So we'll see if that works when the machine gets powered on. Here's the play field. The play field is in all right condition. You can see right here, we have some wear by the bonus indicators, and up here by this voltmeter, you can see there's some paint loss in there as well. So this playfield's not perfect. It's definitely seen a lot of play over the years. I can tell it's also pretty dirty because where the slingshots are, there's a little bit of mylar just where the slingshots are, and you can see the difference between the paint underneath the mylar versus the exposed paint. So it's definitely quite dirty. You can see the same thing on this slingshot as well. So maybe I'll get that to clean up, but I'm not sure because that is pretty embedded into the paint. But still not a bad playfield. I have noticed that there are a couple little bits missing. Right here where these two holes are, there's supposed to be two of these blue plastic posts with rubbers, so those are missing. And then down here by the outlane ball save, there are two posts here and here that are missing. And also this little kicker for the outlane ball save is broken. So eventually we'll have to repair that so we can actually have a functional ball saver. But other than that, this machine is in relatively good condition. And looking at the pinballs, those almost look brand new. They're very shiny. This machine's definitely going to need a rubber replacement because, as you can see, the plunger rubber is disintegrating big time, and we got a lot of dirt down there in the plunger, and a lot of rubbers in this machine are dirty and starting to crack, so this machine is going to get a full rubber replacement by the time I'm done with it. This machine has been upgraded to LEDs, so it should look nice and bright when we turn the machine on. The only thing that I've done to this machine so far is install a lock for the coin door because it was missing, and replaced the back box lock up on the top. It had to get drilled out so I could get access to behind the back box, but that is the only thing that I've done to this machine so far. So let's go ahead and plug this thing in and see if it comes to life. All right, let's hook up the power cord and we'll see what happens. I don't know if the power switch is on or off, so it might turn on immediately when I plug the cord in. We will see. Okay, I plugged it in, and the power switch is off, so let's go ahead and turn it on and see what it does. Oh, there we go. Look at that. There's the neon tube lighting up on the top, and you can see there's 3 LED flashers back here, and those are flashing. The displays are not entirely working right, and I knew this from the get-go because I've seen pictures of this machine running. Yeah, see this? That did not look right at all. It looks like it's maybe the center segment on these two displays that are not working. These ones look okay. And I just noticed that in the camera, the displays are strobing quite a lot, so I'll probably end up changing the shutter speed here in a second. But you can see those two displays on the left, they are not showing up quite right. See that? See how it's not showing up those letters quite right? It looks like the two on the right are working just fine. So that's good. I'll try to repair the displays on the left, but as you can see, the game did power on. We have LEDs in the play field. Looks like some of them are making a good connection. And it looks like not all of them are showing up in the camera just because my shutter speed isn't the most optimal right now. But most of them are working, not all are, so maybe these are really old LEDs. But I'm thinking more that it's just a loose socket problem rather than the LEDs are actually not working. Wow, that neon tube, I don't know if you can hear that. That neon tube is putting some serious load on that transformer. You can hear that. I don't know if it's supposed to be that loud. Maybe we need to rebuild the power supply because the previous owner did say that he thought it needed a power supply rebuild, so maybe at some point we can recap the power supply and just do some testing on it and see if we can get that loud hum to quit, because I can't imagine it's supposed to be that loud. But the machine did come to life. Let's go ahead and see if it starts up. All right, I adjusted the shutter speed, so now the displays aren't going to flash when I'm recording, so that looks a lot better. I'm gonna go ahead and load a credit in this machine, and we'll just see how it plays. We'll see if everything works. One thing that the previous owner did mention is that the rollovers at the top for the word lab are having some issues, and I don't know if it's the actual rollovers or the switches on the ramp, because there's two sets of switches, 3 on the actual ramp and then the rollovers on the play field. So we'll see if that's working okay. So I'm gonna go ahead and load a credit. That was 1. I might need to do it again. Yep, credit's 1. I saw it flash briefly there. I'm gonna turn the volume down because that is quite loud. All right, let's go ahead and start her up. So it does start up. Turn that volume down just a little bit. Let's just see how it plays. Flippers seem decently strong. Oh, look at the displays there on the left. Those two displays are not doing the right thing. We got center segments lit, that's flashing. Looks like we might even have a crack in the display right there. But we'll take a look more at that when we look inside the machine. For now, I just want to kind of test it a little bit and just see what works and what doesn't. Ooh, there goes that LED in the back box. Those displays are not working right. We must have some bad connections or something. This is a very flashy machine. Yeah, I can see the issue that we're having with the top rollovers. It's not lighting any of them when you go down them, so we'll have to take a look at that. One of them lit there for a minute. Okay, so first impressions. The playfield is very smooth. I'm not gonna lie. That's a very nice playing playfield. So we got problems with the displays. We do indeed have problems with the upper switches not lighting and staying lit for some reason. We'll have to take a look and see what's going on up there. It seems like the board set is working fine. I didn't see any NPU related problems because that is something that the previous owner was talking about, is that maybe it had some NPU problems. I didn't see that. It didn't lock up or anything. It played fine. So maybe the power supply can be rebuilt just to see if we can mitigate some of that hum, because maybe we have some leaky capacitors. Maybe we have some other component that is not working quite right, but we'll go ahead and take a look at all that here in a little bit. I just wanted to see if the machine is working, and it is for the most part, so that's nice to see. Now we'll go ahead and remove the glass, and we'll start taking a look at stuff that needs to be looked at. Now, since the last clip, I've actually play tested this game quite a bit because this is a pretty fun machine. So I can tell that all the solenoids and switches are working, but the two pop bumpers here have switches that must be really close together, because sometimes when the ball hits them, they will thump like 10 times. So I'll have to tweak the switches underneath the playfield for those. What I've also done is I took a look at one of the LEDs that wasn't coming on just to see if it was like a socket problem or maybe the LED itself was bad. So I took a look at the 5X LED. You can see it's lit now, and I just unplugged it from its socket, put it back in, moved it around, and it came right back. So it looks like we are dealing with socket-related problems. So when we get to that point, I will show you how to make these wedge-type sockets really nice and tight on those LEDs. So I have the manual for the Strange Science here. And so what we're gonna do is go into its diagnostics and self-test mode. So to do that, I push the button on the coin door, and it says Bally testing is easy as ABC. And the displays don't look correct yet. I haven't done anything with those, but we can read them good enough. So what we want to do is get the keypad out, and to go through the list, it's kind of auto-cycling through the list right now. We can use A to go forward and B to go back. So we hit A. You can see we're going through the different categories. So we want to go to self-testing. Right there. So then it's cycling through the different tests. So let's do, oh, I went past it. Self-testing. This system is really bad. So I'm gonna have to hit enter right at the test that I want. So self-testing, I want to do display tests. There, enter. There we go. So now it is doing the display test, and you can see that in terms of the numbers, it lights all of them up. Well, actually, no, it doesn't. You can see it's trying to do letters now, and it is failing some of the letters on the left displays. So it looks like it's just the center segment, the center line on each display. Yeah, that seems like that's what it is. So the center line on every part of this display is not working. The rest are. Okay, so this is the all lamps test. So it's doing phase A and phase B, because from what I have read, this machine is able to use a single transistor to power two different lights, kind of similar to the later Williams systems. So we can see that all the lamps are flashing, well, all the ones that work. So we can see that most are flashing. The S in the strange needs to be looked at. The 9x score multiplier light needs to be looked at. And I think I'm going to replace the lights in the word science because they are much dimmer than the ones for the word strange, and they are a different kind of LED. So we'll see if I have anything that's brighter. So we can see that most all of the lights are working. Some of the voltmeter lights aren't, but we'll take a look at those. I did notice this. The A light in the word lab, it will never flash when it's supposed to. It always stays just dimly on like that all the time. So I don't know if we have a bad driver transistor that's causing that to come on like that. But once we take a look at the boards in this thing, we will test those transistors out and see if any of them are bad. This one, I imagine, is just a loose socket, so we'll fix that. This one's working fine. Looks like we got a couple on this side lane here that need to be looked at as well. One thing I did do to this machine when I had the glass off of it before, when I was play testing it, I noticed that the ball would always get stuck behind this guide wire back down in here, so you can never get it out unless you took the glass off to get it out, because this guide wire had popped out of its little hole right here. So I moved it back and put it in, and it went in nicely, and so now that's no longer a problem. Another thing I noticed is the switch to go up the anti-gravity ramp. It likes to get stuck. Yep, and now it's complaining about it. One problem I noticed with that switch is it likes to get stuck up here, and so it would be permanently closed, and the game would complain about it every time you turned it on, like you just saw. Well, that's because there is a post on the other side of that gravity ramp. You can see it's slanted. It's not even screwed in all the way. So something happened here. So I'll have to take a look at that when I disassemble this playfield, because you can see that the post is supposed to be screwed in. The screw is supposed to go through the other side of this switch here and into the post. So that, I think, would resolve that problem with the switch getting stuck. So that's another thing that I found while looking around this thing. But let's go back into our test menu and run some other tests. So we'll do that, and we'll go back or go forward to self-testing. Okay, that's the lamp test. Display test we already did. Solenoid. Okay. Okay, here's sound test. Sounds like it just does the one sound. And the next test is the game ROM ID, so it's showing that information on the displays. What other tests do we have? Switch test. Okay. So it's showing which switches are currently closed. I'm going to eject all the balls out. Okay, so we have a problem with the trough switch because it says all switches open, and if I put a ball on it, it still says all switches open. So we need to take a look at that trough switch, but I do think every other switch in this game is working. I did notice the in-lane switches were a little sticky, like they don't want to pop back up. Yep, that was the return lane. This one might have a little bit of an issue here. It does detect it, but sometimes I don't think that one is detected. So just some standard switch tune-up is all this thing needs. There's no serious problems in the switch department. So those are all the system tests that we can run on this machine, and it was basically what we saw before. The displays need work, some of the lights need work, a couple bumpers need to be looked at, the switches need to be adjusted on them, but other than that, there's not really much else that's wrong with this thing. So I did decide that I am going to change out some of the LEDs in this machine. I'm going to add in a little more color, and I'm going to replace the ones that are not quite the same tint. You can see the right slingshot is a little bit more of a coolish white than the slingshot on the left. So things like that I'm going to solve. I'm going to make it all look the same. I'm going to add some red lights for the Atom Smasher because this plastic piece is red and they just have white lights under them, so I think that would look a lot better with some color. They did do that with the anti-gravity ramp plastic. They have a couple blue lights in there, so I'll leave those in. It's going to look very similar to what it looks like now. I'm going to leave the vast majority of the lights in this machine, but I'm going to add in a little bit more color just to make it look a little bit better. So before I clean up the playfield and replace the rubbers and do my LED upgrades, this is what it looks like before I did anything to it at all. So what I'm going to do now is I'm going to go underneath the playfield and I'm going to see if I can upgrade these science lights with a different kind of cool white so that they're just as bright as these, because the lights under here are different than the lights here. So I'm going to do that. I'm going to try to fix any of the other lights that are having trouble lighting or not lighting, like those. I'll see what's up with the lights in the back for the lab. And I might put different LEDs in the first 9 bonus indicators as well, because they look a little bit dim compared to the rest of the cool whites underneath. So I'm going to be doing some LED improvement and seeing if I can get the ones that don't work working. And I will show you what that looks like when I'm done. And opening up the playfield, you can see exactly how much dimmer those other LEDs are. These are the brighter ones on the left. You can see pretty bright. But if you look at the ones here, look at how much dimmer those are. So I'm going to replace all those with a frosted cool white LED, and that should make it look much brighter. Well, you can see right away the difference. These are the old ones that were in there, and I just put in these top 2 new ones. Look how much brighter those are. And the difference is just as big on top of the playfield. So I'm going to go ahead and replace the rest of these, and I'll show you what that looks like. Look at that difference. Just as bright, if not brighter, than the ones that spell strange. So that is a major improvement. So now what I'm going to do is replace all the bulbs in the 1 through 9 lights, because they're the same dim bulbs that were in the science lights. So those will look much brighter. And then we'll take a look at this S light and get that to work. And for whatever reason, the N light is a slightly different tint than the rest of the LEDs. So maybe it came from a different batch. So I'll take a look and see what I have, and also go ahead and fix all the other ones that are either having trouble, like this one's a little dim and this one's not working at all. So I'm going to go through the game and see if I can fix up the rest of the lights. So I haven't went through and replaced those LEDs yet, but I did find something quite interesting. In the solenoid test, it tests the light in the back box and the neon tube up at the top. But you can see that it says neon, it's attempting to say neon, but it's lighting the back box light. And if I go to the next solenoid, you can see it lights the neon tube, but it says back box. So the reason it's doing that, I believe, is because the connections for the solid state relays are swapped. So let me show you that. So here's the inside of the back box, and we'll take a better look in here once we start doing some hardware related stuff. So up here we have our soundboard. This is the Bally 6803 control board, and it is a combination MPU and driver board. And then down here we have our power supply board. And then this is that little handmade board that I found that apparently is supposed to light the balls in the trough. Originally, this game would have come with a circular fluorescent bulb like that, and I did order one, so I'm going to be putting one in here to replace this LED at some point. But as you can see, the LED is dimly lit at all times. It'll be like that in game over mode as well. But you can see it says back box, but it's lighting the neon tube. So what I think needs to happen is I need to swap the two connections on these solid state relays because those control the LED and the neon tube. So I'm going to go ahead and shut this thing off, swap those connections, and we will see how it reports itself during the solenoid test. And yep, that was it. I swapped those connectors and now it says neon and it lights the neon tube. If I advance it to the next one, which is the back box, you can see now it lights the back box LED. So those two connections, these two here, were swapped. So now they're in the correct position. All right, so I fixed about 99% of the lights in this machine. I swapped all of the lights in 1 through 9 with much brighter ones, so now they are nice and bright. The only lights that I'm still having trouble with are the 9X playfield scores light here and 2 of the lab lights up there. Now, I think that part of this is also a transistor problem because I can get the A light to dimly lit, but it won't flash like this. And it's the same thing for this one. If I mess with the sockets, I can get them to light dimly. Both the A light and the 9X light are driven by the same transistor. So I think we might have a bad transistor on the driver board. So we'll have to take a look at that once we start pulling the boards out of the machine. I cannot get the L light to work, so I'm going to have to put the back box down and just reach through the hole to look at this one because I can't see back there. So that'll get fixed eventually, but all the other lights are working just fine now. So I think it looks much better. So what I want to do now is I actually want to replace the LED that's in the back box because since it's an LED, when it flashes, it goes full on, full off, full on, full off really fast. And so when it's flashing that fast, it's kind of just a little bit too much. Plus this light is so bright, it's washing out the backglass colors. So I want to put something a little more period correct into this back box. So I went on eBay and found this. This is a circling bulb or a circular fluorescent bulb. And this is what would have come in the machine from the factory. This is a 22-watt bulb, and it is an 8-inch diameter bulb. The part number is FC8T9. So if you're looking to put the correct bulb inside one of these Bally 6803 games, this is the one you're looking for. Now, this is a new old stock bulb. This package says copyright 2002 on the back. So why did I buy one that was so old? Well, I didn't buy it for the bulb. I bought it for the center adapter piece because as you can see, it screws into an existing light socket, and that's how these machines were configured. I could not find this piece anywhere, and so I looked on eBay and I found this sealed bulb in the box. So I figured I would get this. We'll see if this bulb works, even though it's 23 years old, but since you can still get these bulbs for like $10 on Amazon, it's not a big deal if this one doesn't work because I can easily replace it. So before I replace that bulb, I want to show you what the LED looks like when it flashes so we can compare the two. So this machine operates kind of funny. If you push the second button when you're in game over mode, it'll kind of go into like an attract/tutorial mode, and it will flash the bulb plus the neon tube while it tells you how to play the game. So I'm going to push that button. It'll say Strange Science, and then it'll flash the bulb. So that's what that looks like. Let's go ahead and install that circling bulb and see if it works. So we'll take out this LED and we will install this new old stock 23-year-old circling bulb. All right, that is in there now, so we will see if it works. I'm just trying to get some of this wiring out of the way. It's not going to light up immediately, but it should light up here momentarily. There it is. Look at that. And the main reason I wanted to install one of these is so, since it's a regular light, it'll have a softer flash when it flashes. And yes, that looks so much better. It's no longer washing out the backglass colors, and it actually looks quite good with a more warm look. So I'm going to put it back in that audible attract mode again, and let's see how it flashes. Yeah, that's definitely a lot softer of a flash. That's much nicer. So now, because I've got most of the under playfield lights working, and I replaced the light in the back box, now I want to go and do some hardware stuff. So I'm going to be taking the boards out of the back box. I'm going to be removing both of the displays just to look at them, and we'll see if we can repair this module here. It's 2 displays on each module. So we'll go ahead and do that, and we'll see if we find any problems that need to be fixed. Well, I think that left display is fried. Watch what happens when I turn on the game. Watch the leftmost display. Did you see that? It arced big time onto one of the display segments. Now, earlier I noticed that there looked like there was a crack right here. You see how when these 2 segments are lit, there's like a little bit of that orange coming out of there? That should not be happening, and it's doing it on this display as well, which is part of the same module, and these ones that are working don't do that. So I think that this display is not going to be repairable. I'll still look at it, but I do think that LED displays are in this machine's future. Well, you know what? I think the best thing just happened. I was behind the back box and I was tapping on the PCB of this display module a little bit, and look what happened. The center segment came back. You can see the N is being displayed properly, and all the words are being displayed properly now. It's not perfect. It'll still do some kind of weird things sometimes, but I think our whole issue is that we just have some loose solder connections on this left display module, so I think I can save it. I don't think I'm going to have to get LED displays for this game, which is great. So let's go ahead and take a look at those displays and take a look at everything else in the back box. Wow. All right, so here are our 2 original Bally display modules. This is the one that was on the left, and this is the one that was on the right. You can see the one on the left is missing this little paper shield here, but that's not really a big deal because there's no metal inside the cabinet that is very close to that area. So on brief inspection of these displays, I can tell that the one on the left has been reworked because these connections for the cable that attaches it in the back has been reworked, and this one I can tell has not. I can also tell that the connections that actually connect the display itself to the PCB have been touched up as well, and I don't think that, well, they do look like they've been touched up on this one as well. I can see some solder flux residue, so I think these displays have been worked on before. But when I was touching this left display, when it was assembled, I was touching around right here by where this chip is, and that was making the center segment come back. So obviously I need to reflow some connections around this part of the display, and that should fix that problem. Here's the back of the display modules. You can see there's quite a bit going on back here. I can tell there's been some rework done. The connections for the cable on this display have been reworked, and it looks like maybe the display connections on this side have been touched up as well. What's funny is this is the display that was working just fine, but looking at the pin headers, there's a solder bridge on this one that is not existent on here, and I know that there's not supposed to be a solder bridge there, so I'm going to go ahead and remove that. These displays are the original vacuum displays. You can see the little end of the, I guess you can call it a tube, where they sealed it off, so there's no air inside these displays, and if you tap it with your finger, you can see it's actual glass. So these displays take around 190 volts to run. So you definitely need your high voltage working if you want to see these things come to life. So what I'm gonna do is I'm just gonna go through these displays, look for any solder connections that seem suspect or cracked or bridged, like this one. I'm gonna reflow them, and we'll put the displays back in the machine, and we'll see if everything works correctly. And here's one of the benefits to having a real scientific grade microscope is you can look at these traces very closely and find crack joints super easily. So let me show you what I found. So in the microscope view, you can see the third joint from the right, this one here, has a big crack right there where the leg meets the solder. So that is something that needs to be fixed. So I'm going to go through and look over both of these displays under the microscope, and once I find that everything is okay, then we'll go ahead and plug these back into the machine and see if they work. All right, the displays are back in the machine, so what I ended up doing is reflowing all of the pin headers for the cable connections on both sides, and I also did the connections going to the displays themselves on both sides. And on this display, I reflowed this chip here because I was pushing right where this chip was, and that was what was bringing the center segment back. So I reflowed that on the left display. So now they're connected, so let's go ahead and turn the machine on and see if they still work. And yes, they do. And I noticed that before, whenever I turned on the game, the displays would have one of the segments be very brightly lit for a few seconds. It did not do that this time. So obviously the displays are now working just fine. And you can see the machine is now running its display test and everything looks just fine. It's drawing the letters perfectly. And so that is one major thing repaired on this machine. So now what I'd like to go ahead and do is pull out all of the boards from the back box and just take a look at them and see if everything's okay. And then we can test that suspect transistor on the CPU board and see if it's actually bad. And one thing I will do also is I can see that the connectors back here are not labeled, and I would hate to put one of those in backwards or in the wrong spot because the game is actually working. So I'm going to go ahead and label those with a Sharpie as I take them out, and then I will know for sure where they go. And it looks like I'm going to have to remove the displays again to get to the power supply board. So I'm going to go ahead and do that first. It's not even tight. Well, there's what it looks like behind there. And by removing that modification board, we have a name of the person that did this, Rick, back in September of 1994. So this machine was loved by somebody else back in the early 90s. So that's kind of interesting to see. So what I'll do is I'll go ahead and clean up back here because it's a little bit dirty. And I'm going to try to make this wiring a little less messy. You can see there's been some work done, like we have a zip tie here. This ground connection here is broken, and the other side of that wire is in this harness. So we'll see if I can repair that. And a lot of the screws that were holding in these boards were very loose. So when I put them back in, I'll be sure to tighten them down. And another thing I noticed is that not all of the wiring was put back through the wire routing plastic pieces. I didn't undo any of the wiring out of that. So that's exactly how it was. Those two aren't being used. There's one down there that isn't being used. So I'm going to go ahead and redo this wiring to make it look a little nicer. As you can see, I've gone ahead and labeled each of the connectors in the machine so I know where every one of them goes. So I'll go ahead and make this look better. For now, let's go ahead and take a look at those boards. All right, our first board that we're going to take a look at is the power supply board. And I don't think it has been worked on because everything looks original. I don't see anything that's been changed. I do see that we have some blue tape that is holding on the paper shield to the back of the board. So I'll go ahead and remove that. We'll take a look at the other side. Well, taking off the paper shield, it looks like we have a little bit of what looks like to be maybe old nicotine. So I'm going to clean that off before I put that back on. And here's the back of the board. You can see it looks pretty good. There's a little hot spot here because there's a big resistor right there that I assume gets very hot. It looks like there's a little bit of rework. I can see some solder flux residue in a couple places. So maybe things were just reflowed or maybe components were replaced. The rework areas on the back of the board are this little capacitor right here, this leg of this diode, and the leg of this resistor. But I don't think they've been replaced, so maybe the connections were just cracked at some point and they needed to be reflowed. So as far as I can tell, this power supply board is working just fine. But what I want to go ahead and do is verify that these 3 electrolytic capacitors are in okay condition. Now, if this machine had not been powered up in a very long time, I would want to reform these capacitors first, but since the machine's been turned on for plenty long, those capacitors don't need to be reformed. So the first thing I'm going to do is test their ESR, their equivalent series resistance, and I'm going to do that with this. This is the Capacitor Wizard, and it is an in-circuit ESR tester, so you don't have to remove the capacitors from circuit to test their ESR. So it's a good test to kind of get an idea if your capacitor is healthy or not. It's not the end-all be-all test. That would be the leakage test. But what I'm going to do is if these capacitors measure good ESR, I'm going to leave them in the game because the power supply is working just fine. So the first one we'll do is this big black one. This is a 11,000 microfarad 20 volt capacitor. And that capacitor should have an ESR very close to 0 ohms. So when I touch the 2 leads of the capacitor, this meter should go up almost to the 0. It should be way up in the good. So let's see what we got. And yep, that capacitor has real good ESR. So that capacitor is healthy. I'm going to leave it installed in the power supply. This big blue one here is a 350 volt, 150 microfarad cap. And this one should have a relatively low ESR as well. It should be in the good. And that one is good as well, around 0.3-ish ohms. So that one is fine. And then this little one that's right next to the big voltage regulator here is a 50 volt, 2.2 microfarad. And the worst case ESR for that capacitor is 4.5 ohms. So as long as it's above 4.5 ohms, which is about right there, it should be just fine. So let's see what we got. Yep, right at 0. So that one is also really good. So it looks like all the capacitors on the power supply are still in very good condition. So let's move on to our next board. All right, here's our sound board, and this board looks good as well. And I was looking over that power supply board a little more, and I noticed that there were flux residue marks on every capacitor. So the power supply board has been recapped. And I can say the same about this one because if I flip it over, see these marks here where there's solder flux residue? Those are all the capacitors. So these boards have been recapped. So I imagine that all the capacitors on these are going to be just fine. I'm still going to do the ESR test though. And both boards I've looked at so far don't seem like they have any cracked solder connections or look like they have any sort of damage at all. They all look perfectly fine. So first let's test the large capacitor. It's a 4700 microfarad, 35 volt. This should have a very low ESR. Yep, that one is fine. This one is 1000 microfarad, 35 volt. It should be extremely low as well. And it is. This one is a 470 microfarad, 35 volt. Also should be extremely low. And it is. This one is a 47 microfarad 25 volt. This one, the worst case, should be 0.9 ohms, so it should be lower than that. And it is, so this one is fine. And this little one here is a 1 microfarad 50 volt. The worst case for that is 4.5 ohms, so it should be higher than that. And yep, just over 2 ohms, so that one is perfectly fine. So the boards in this machine so far seem to have a clean bill of health, but this one does have a little problem that I've seen with these Bally 6803 soundboards. This is the main volume potentiometer right here, and it is very scratchy because sometimes when I'm playing the game, the sound will go in and out. So what I need to do is just spray a little bit of contact cleaner in there, and then we'll just work it a bunch of times. And this potentiometer has a Phillips screw head on it, so if you really want to work it nice and fast, you can just take a screwdriver and just do this about 5 or 10 times, and then that'll work the contact cleaner throughout the potentiometer. So when I install it back in the game, that should not be a problem anymore. So let's move on to the CPU board. So here's the CPU board, and looking it over, it looks pretty good. It has had some modification, as you can see, the wires attached here for that little modification board. And I can tell that there have been at least 4 transistor replacements for the lamps, because these 4 transistors here are different than all the other ones, and that includes the transistor that I think is suspect. So what are the chances of that transistor failing again? And up here we have the solenoid transistors, I believe, and those look to be all original. And as I've shown before, the battery on this board has been removed and it now has a NVRAM chip, so it no longer needs a battery to save its game settings. But these 2 capacitors here are original to the board because they have not been worked on. There are no marks under them. So I'm going to check their ESR and see how they're doing. So these capacitors should have a very low ESR. This one's a 470 microfarad 25 volt, and this one's a 470 microfarad 16 volt. Good. Good. So those capacitors are fine. So the transistors here that drive the lights in the machine, they're actually not transistors. They are silicon-controlled rectifiers. And there's a little bit of a different process you have to go through to test those, but I don't have all of the parts needed to do that. So for right now, what I'm going to do is just put my multimeter into diode check, and we are going to compare a good SCR to the one that I want to test, just to see if there's any differences, and that'll kind of clue me in as to, hey, maybe that's bad. So the one that we need to test is Q33. That's this one right here, and it has been replaced before. So what we need to do is put the positive end of the meter on the anode, which is pin 3, so that's right there, and then the negative end on the cathode, which is pin 1. Okay, we get 1.8 volts. Let's see what that looks like on a good SCR. See if there's any difference. That one we don't get anything. Let's try this one. Okay, that one we get 0.6. What about this one? Nothing. It's weird. Most of these just read open circuit, but if I do this one here, it reads as 0.6 volts, and then the one that is suspect is reading 1.8 volts. And it seems like the rest of them just say open circuit. Well, I'm noticing now that if we go between the cathode and the gate, we get a 0.6 voltage drop, 0.7, 0.7, so that should be okay. Let's check Q33. Let's see what that is. 1.4. 0.7. 0.7. I'm testing other good ones, 0.7. Let me test one of the other ones that's been replaced before, and we'll see what it says. 0.7. Okay, so I do think that Q33 is bad, because if every single one of them has 0.7, and then I test Q33 and it has 1.4, it's probably not completely dead because we've seen it dimly light up the lights that it controls, but I'm pretty certain that this SCR is bad and I'm gonna have to replace it to get those lights working. So I'll just have to order some more of those, and that will be a very simple fix. So other than this SCR that I'm gonna have to replace, the CPU board actually looks pretty good. I don't see any cracked joints on the connectors, on the components. If I take a look at the back of the board, you can see it looks pretty good. You can see some solder flex marks from where transistors have been replaced. Looks like maybe in the past, right here has had some work, and that goes to a resistor and a diode. So maybe those had to get replaced at some point. Maybe they failed. But other than the little bit of work that's been done, this board is in very nice shape. Let's move on to the last two little boards. And here are our last two little boards. I didn't have to pull the solid state relay board out, but I did just for the sake of looking it over, and everything looks to be completely fine. This board's never been worked on. Makes sense, it's a very simple board, not a lot of stuff to fail, but this board is in good shape. Here is our little mod board. This is kind of interesting to me because the person that did this, I assume it was Rick, obviously was very well versed in electronics, because as you can see, he has drawn colored lines with a marker that are red, black, and it looks like maybe a different color on different spots throughout the circuit. I think what he did there was he drew the voltage potential of the circuit in different locations. And so that would make troubleshooting really easy, because then it would show you what part of the circuit is on like 5 volts, for example, and which part is connected to ground. So that's what the front of this board looks like. If I turn it around, you can see there's not a lot on the back. We do have a little capacitor here and some more markings. Now, since I'm not an electrical engineer, it's a little bit out of my wheelhouse to try to reverse engineer this circuit and see what exactly it's doing in the circuit. I could look up the part numbers on these chips and figure out what they are and what they might be used for, but since this is a custom board that was made by somebody, I don't have a diagram to look back on, and so I don't really know what the original designer had in mind when making it. I suppose I could do a separate video on it and try to kind of sort of figure out what it's doing. And I don't know if it's working, because when I have it plugged into the game and unplugged, nothing changes. So I don't know if this board is even working. So a lot of unknowns with this board, but if anyone has any idea about what this board might be doing in the circuit, let me know in the comments. So those are all the boards out of the machine. Every one of them looks to be in very good shape. So what I'm going to do now is put the boards back in, and we'll clean up the wiring and make the back box look really nice. Well, I was going to do one of my nice little time lapses to kind of show you the work that I needed to do to rework the wire harness, but it ended up being so much work and I was recording for so long, I just decided I'm going to show you what it looks like right now. So change number 1. All of the wire harnesses have now been routed through the plastic pieces that are designed to route the wires. And so everything is much neater and it's a lot more out of the way. Change number 2 is I trimmed the cardboard piece that was behind the modification board because it kind of extended to up there by where Rick's name is. It didn't need to be that big, so I trimmed it. I cut it down to be the size of the board itself. So I think that looks better. And I also went ahead and took the connector wire that goes down into the playfield and I wired it with the main harness. So now it's not just sticking out and going down like this. It's wrapped in nicely with the harness. And I think one of the best changes to this is that since the wires are through the little plastic pieces now, when you go ahead and put the light bulb back in, you don't have to push any of the wiring back because it's as far back as it can go. So when you put the light bulb in, it's not going to come close to touching the wires because now they're actually in the correct position. They're not touching the bulb anymore. And it just took a lot of time to rework the harness and untangle different things to get it into a much neater state than what it was before. So it definitely looks a lot better than it did the first time. And I also took this little cardboard piece off. There's another transformer right behind that sticker that provides the 240 volts for the neon tube. And I went ahead and replaced a missing screw that is right there That is one of the screws that holds on this little metal piece with the 3 flashers. So now that's nice and tight. And I also went ahead and wiped down and vacuumed out the entire back box because behind the power supply especially, there was a bunch more of that brown, what I think is nicotine. So I just wiped down the whole back side of the back box and vacuumed it out. And so now it's all nice and clean. So that is what our back box looks like now. And with the bulb back in, you can kind of see now there's at least a good inch and a half of room behind the bulb. The wires are no longer up right against it. Before I had to push the wires back to even get that to screw in. So that is much better. And I just noticed something about that modification board. When it says lamp lit for ball and trough, it's not talking about one of the lamps that's under here. It's talking about this LED that is on this board. So right now, I have a ball in the plunger, and that LED is on. If I go ahead and shoot the ball a little bit so that it goes off of the plunger switch, watch the LED on this board. It goes off. So clearly that board is doing something. I don't know what it's doing because nothing changes when I have it plugged in versus not plugged in. But clearly it's doing something. So I don't think we have any problems on that board. And I've also gone ahead and cleaned up the back glass, and let's just say it had a lot of nicotine on it. So I gave it multiple passes on both sides. Front with just some regular glass cleaner and the back with some wet wipes. And I can tell just by looking at it on the machine, it looks a ton better. The displays are a lot more clear now that I've cleaned that up. So I'm glad I went ahead and did that. I had no idea that it was going to be that dirty. So I think it looks great. And so that is going to be part 1. In part 2, we are going to start solving all of the problems on the playfield. It's going to be the main scope of the next video. And we may start doing the playfield restoration as well, depending on how long that takes. So look forward to that, and I will see you in my next video.